Okay. Hi. We have chosen problem statement 4. We are Akshara, Ola, and Raman in the group. So this is our presentation. We have Colorado Workforce Intelligence Platform. That's our project name. The problem statement that we have created, making use of the data, is job. So we have a platform where job seekers, students, veterans, recruiters, and even policymakers, they can make use of this app. So this is done in the intention of helping people who are going through real problems while applying for jobs, keeping in mind all the problems. Job seekers, when they apply to jobs, the jobs and companies, they have a lot of fake jobs or ghost posting, or there'll be no public job board surfaces. So we have taken into consideration for all that for job seekers. And for the students, so suppose a student wants to learn something, suppose student is interested in the engineering field, but he doesn't know what to study and how the job market is. So he can go and check what field he's interested in, and check what the employers are expecting and what he should actually learn, instead of just the textbook or the academics. And for the veterans, so they leave the service and they have very high skills, but they cannot translate to the civic job easily. So the job search system, they help military veterans to find the job using the occupational codes. And the policymakers, so we designed the workforce, we train the programs from ESCO and ONET taxonomists, and they are so like a lot of jobs are years behind the active employer demand. So you can actually see the trending skills, emerging skills, that are invisible to the people. So everybody can make use of this application. And the data given to us, Colorado CSV and Colorado Process CSV. So Colorado has more in depth. It has the ghost jobs, the federal government jobs, or the rapid codes. Rapid codes are just the apprenticeship, where you get trained and get paid as well. And MOC codes, these are military occupational codes. Those are tagged by the employers. Where even those veterans can apply. And CIP codes, these are academic program classification links. So the data is very detailed. We have made use of each and every variable and feature of the data to do this application. And Colorado Process has the raw skill, taxonomy skill, and correlation coefficient. It has the confidence score and taxonomy source, whether the mapping is from ESCO or ONET. So the correlate matters. So if it's 1, then it's exact match to the taxonomy. If it's 0.65, then the threshold that is used in this application to flag. If it's less than 0.65, it has no confident bucket. The skill is newer than the database, and this is an emerging skill signal. So this is what we are using. And system architecture is, we are loading the data. We are loading both the CSVs. So we have 24 analytically relevant columns, Boolean flags, and we have aggregated 165664 skill rows, and we have the function build vectorize. It produces a sparse matrix of shape of this shape, and it is held in memory for entire session. And the platform statistics, we have total job ghost count, federal count, apprenticeship count, and MOC, the military count computed, and it is passed in each tab module as arguments. And tab multi-lender, we have 5 tabs, tab 1 to tab 5. Each receive shared data objects as function arguments. So no tab imports data directly. This is our structure, our project structure. And so coming to the 9 NLP techniques that we have used in this, so TF, IDF vectorization, cosine similarity matching, uh, is the how similar is the skill regardless of the description length or exact wording, and skill gap analysis. So top 12 skills that a job ranked by the correlation coefficient, and keyword that is checked against the user text producers. It produces a priority ordering learning roadmap. So the skill that matches the job that matches the highest will be at the top, and the job that matches the lowest will be at the bottom. And we have emerging skill detection, where low correlation coefficient signals, and the taxonomy has no bucket for a skill. So multiple employer, they co-occurrence the separate genuine signals from the typos. So a ghost job language analysis, not everybody will reach out to you when you apply for a job. So we have that analysis, and we have credential inflation detection. The posting requires 2 or more education level above the above the group minimum are flagged as a credential inflation. Like I need you need MTech degree with these skills, but a person will not have a master's degree. He will have a bachelor's degree with all the required skills, but he just couldn't afford the education. But he could still apply for the job. So we also flag those kind of jobs. And MOC code matching for veterans, and skill frequency analysis, count of the taxonomy skill values, and description quality scoring. So 5 dimension rubric, we take length, salary, transparency, education clarity, experience clarity, and specificity. So scored 0 to 100. And we are using TF IDF vectorization and cosine similarity. These two are the main techniques that we are using in our project. And we have emerging skill detection, where you can detect the you can detect the skill. So if the employer writes, I have uh, I have this, so he writes the description, and he will give the number of experience years of experience, the salary, and everything. You can actually detect the skills that is required. And we have 5 user interface: job seeker, student, veteran, market intel, and recruiter. So the last one is will be helpful for the recruiter. So our app is taken into consideration from student to job seeker to the recruiter as well. So technical implementation, we found these 7 bugs, and we fixed before the deployment. This is actually the learning that we have done. This is the very good learning that we incorporated before while doing this project. I think learning is mainly important while doing a project. And these are the limitations and methodology transparencies for our project. And so for policy finding from Colorado data, emergency skill gap, correlation, credential inflation, like I explained, and registered apprenticeship pathways, and geographic salary variance for identical roles. So this is what we have built. We have fully deployed the publicly accessible Streamlit platform. It transforms to raw NLX CSV file into a structured workflows intelligence system, serving 4 user populations simultaneously. So going to the demo. um yeah, so this is the demo. Here, I can just describe my skills. Python, and I say HTML, I have 5 years of experience, and so I we have the filter high job goes jobs, federal contract jobs only, apprenticeship pathways only. So I let me undo this. Okay, so I found 10 positions where you can see the 33% is the most. So it is at the top, and we have 19, 18, and it just goes down. And if you open this, you can see the math score is 33%. So skills to develop for this role is nothing. But whereas you can see for this one, less matching, these are the skills that they need to develop and what they are already matched. So this is finding the skill gap. And so this is also for the adjacent career. Also, you can do the same thing, and you can find the adjacent career where you might not be eligible because of your background, but your skills are eligible. So this does just that. And going to the student, so you can select a field or you can enter your field of interest and analyze career field. It says it gives you the average minimum salary, apprenticeship paths, federal job, matching positions, what you need to learn, skills that requires, what you need to, how much it is trending. So what is the trending? You can also see the salary overview if there is any job matching, available positions. So this is for the students completely. And going to the veterans. You have veterans have something called MOS codes uh, that describe their job. So if I say 11B and run career translation, so it gives you all the jobs that particular veteran is uh, eligible to put. So it takes 2 stages. Stage one, direct MOC tagged employer match. So a few jobs will be tagged MOC, and but few jobs will not be tagged, but it will have the similar skills. So cosine similarity will it's ranked based on the cosine similarity. So that is the stage two. So this is about the veterans. And market intelligence. It's the analysis of everything, the ghost job analysis, the credential inflation analysis. If you scan, so if there is any credential inflation scan, you can, if there is anything for your position, it will come up here. Right now there's nothing, so there's nothing showing up. You can check the salary fairness, so the average minimum salary, the highest average salary city and the statewide median, and ghost job analysis, how many total posting, how many ghost jobs, how many are real job, and what is the ghost rate. And you can also run language pattern analysis for the same thing. So it will detect it using TF-IDF. And yeah. So, and then we have education job alignment. This is also one of the main important functionality. It has posting linked to education program, posting without CIP codes. So CIP code is the job uh, the job qualification code, and the employer count, how many employers are there in those particular CIP code. So you can see here 11 x-axis computer science, 51 x-axis profession. So this is, so for example, so we have given the example. And we have also explained the methodology, data transparency, and known limitation all of our all of our requirements. So this is the end-to-end platform. Everybody can make use of it. And this is our project. Thank you very much.